The Burnout and Casting is the title for our next presentation. After discussing the procedure of investing the removable partial denture framework and the selection of the metal, the proper metal, to construct a removable partial denture framework. Now, dear students, we are going to discuss the burnout and the casting of the removable partial denture framework. Now, burnout or wax elimination is the removal of the wax from the mold, usually by heat. It consists of heating the investment in a thermostatically controlled furnace until all traces of the wax are vaporized. After preparing the investment within the investment ring, and after initial setting of the investment, there is after 1 hour, then the investment ring were placed in a furnace upside down to start the burning out or removing of the wax pattern from the mold. This could be generally done. Mainly the purpose of this, the burnout, is to drifts of moisture in the mold and it vaporize and thus eliminate the pattern, leaving a cavity in the mold, and it expand the mold to compensate for the contraction of the metal on cooling. Now later on, after the burnout completed, now the method that we need to go through the burnout process is either there are two techniques for this. It's either slow technique or rapid technique. The slow technique is sometimes the burnout procedure starts with cold oven and then gradually raise the temperature. While the rapid technique, the heat of the furnace, heating the furnace up to 200 centigrade and hold this temperature for 30 minutes, most of the wax is by then eliminated. So this is depend on the type of the furnace as well as the type of the investment material and the alloy that you would like to cast later on. The casting, it's a process of using force for quickly injection of molten metal into the mold cavity. This force may be either centrifugal or air pressure. Okay, now the technique of the casting depend on the machine that we are using for casting purposes. So what's the type of the casting machine? We have the most commonly used centrifugal casting machine at the image on the left side, using the centrifugal, and of course this is the most commonly used, whether this is electronically or can be used manually. Then the air pressure, using the machine on the right side, showing the air pressure machine used. Of course, the air pressure we can use either gas oxygen blowtorch. That means we will melt the wax, we will melt the metal using gas oxygen blowtorch, or we using electrical muffle surrounding the metal, so this will produce a circle of electronic circle to melt the metal, or the induction method, which is the provide a rapid and accurate method of melting the metal. That means all the metal at once will melt, not gradually. And this actually in most of the casting machine that we have, the most accurate one. Casting machine, of course, require heating source to melt metal, and casting force in any case, either too much or little force is a desirable. If too little force is used, the mold is not completely filled with the metal. And if it is too much force used, this may give excessive turbulence, may result in entrapment of gas in the casting, also can be cause a mold fracture as well because of the pressure going into the investment material at this process. The method of melting alloy, we have different methods. For example, so generally the machines that we have is either air pressure or as I mentioned previously, centrifugal or air pressure. And with the air pressure, of course, we will use gas oxygen blowtorch, electronic muffle, and induction. Now, the methods of melting alloy are different. It's either the oxygen acetyl flame. So in the image at the left upside here, we are using oxyacetylene flame. We require control to use the correct ratio of oxygen to acetylene, because if it is too much, result oxidation, while too much acetylene will result in carbon pick up by the alloy, which must be avoided. Okay. Now the electric melting is using this machine. Is this machine showing the method of melting the metal in terms of using electric melting. The properties of the electric machine is this is the electric machine here. The machine is driven. By the way, the electric and the induction, most of the machines are look like the same in terms of the process, because they're using it may be the same, because the electric melting using generating electron circle around the metal to melt and the induction as well. So and somehow the system of the machine probably the same, but the name will be different. Now with the electric melting, the machine is driven by an electric motor. Instead of spring, the machine produces a high frequency current. As I mentioned, the circle of the frequency current, electrical current, which passes through a water-cooled coil. This high frequency alternative field produce current, generate considerable heat in an alloy which has a high electrical developed and melts the alloy. The cooling of the coil is essential to prevent melt of itself during the process. Now, note that the water pressure must be approximately 25 to cool the coil satisfactorily, and unless this pressure is produced, the machine will operate. Now, in terms of the induction melting, provide a rapid and accurate method of melting metal. Starting with for example, the zone that we are using with the oxyacetylene blowtorch, the two type of torch tip, it's either multi-orifice or single orifice. Now the composition, the zones of the flame of the blowtorch, starting with the mixing zone, it's cool, colorless zone, while the composition zone is greenish. You can notice this is the invisible, which is a non-composition zone, or it's either mixing or non-composition zone, and the composition zone, which is the green here, the greenish blue zone in which partial composition takes place. This makes an oxidizing the alloy. Now the reducing zone here, the reducing zone, which is the dim blue tip, it's the hottest zone on which we are working with. So with this zone, at this point with this zone, we will focus on the metal using in terms of melting the metal. Now the oxidizing zone is the last zone that we have, which find composition between the gas and surrounding air occur, and it makes an oxidizing the alloy. So if you put this flame on the metal, you will have an oxidizing alloy. Well, we should use the reducing zone here to make sure that this is the hottest one, which is give us a proper melting for the ingots. Now, the procedure for the casting start with the casting machine is prepared by selecting a proper crucible. Must be clean or lined with asbestos. Of course, the casting machine is wound and lock, locked in position to make sure that we should prepare the crucible former, the location in the machine. We adjust the location of the casting ring even before we start investing, because this process could be take for about 2 hours, 1 hour for the investment and the initial setting, and then burnout procedure within probably 1 hour, and then later on casting the metal. So we should adjust the casting ring within the crucible of the machine, and we should use the clamps to make sure that it should be located properly, and the orifice and the opening of the investment ring directly to the opening of the crucible on which the metal we will place and melt it. Then we can put the metal inside the crucible former. Make sure we will use the properly the flame at the reducing zone, controlling the ingots. Sometimes we are using ingots step by step to make sure that they are melt, and then add the other. And this depends on the machine itself. If you are using manual melting, this will be ingot by ingot. While if you are using the induction or electronic, the system will be different. Now then, we should reducing the flame on and focus on the torch on this part, on the ingots. Make sure that all the parts were melted, and then casting ring is removed from the oven and then placed in the casting machine. And important to be to not overheat the metal, to leave the casting ring in the machine more than 2 minutes before casting, overheating before casting. And of course, overheating will destroy some of the components of the alloys as well. Then the molten metal has a bright surface mirror on the upside, on which then the casting machine is released. Make sure that the casting machine released, so with the pressure forcing the metal into the opening of the muffle of the casting ring. The hot casting ring is then plunged in sink, or it depends, either quenching in cold water or keep on bench to be cool. Mostly we are using on bench cooling. This will give enough time for the metal to solidify, to give a properties for the casting restoration. After, of course, finishing this procedure, or after complete cooling of the casting ring, after removal from the after the final cooling on bench, then the investment material removed either by using sharp knife, or sometimes we are using electrical hammer to make sure you are removing the investment properly away from the from the design, metal design. Then the appliance or the framework will be moving to another step, which is we will discuss that next week by starting with finishing and polishing system. Now, with the centrifugal casting, I would like to say it is the centrifugal casting is one of the simplest way. It's simple in design as the simplest way to be used in terms of casting the metal. Uh, Whether you are planning to cast, for example, small pieces in term, for example, crown and a bridge, or you would like a full restoration like in full palatal plate or any large design, so this will be suitable. But we should put in our mind that we should focus on the clamp and that will hold the casting ring on it. Bearing in mind that most of the rings we have a ringless cast or cast with metal rings, and this is depend on whether you are using asbestos or not, of course. While the air pressure casting machine, with the air pressure type of machine, either compressed air or some other gas such as carbon dioxide or nitrogen can be used for force the molten metal into the mold, of course. The gas pressure is applied to molten metal through a suitable value machine. This type of machine is satisfactory for making a small casting. Generally, we should put in our minds to how what the type of the metal that we are use and the temperature of the preheating of the casting before casting, and what the temperature and the melting point for the metals that we are using. Now, the most important thing through the casting, we should put in our minds many things which may affect the product, and these are the casting problems. The casting problems, you either have a successful casting or you may have problems, and most of these problems can be solved while others cannot be solved. That means you need to reconstruct the prosthesis again. Now, one of these are the roughness. We have roughness within the final casting framework. The surface of the casting should be smooth, although finishing and polishing are still required, but this should be mimic the same wax pattern before we are casting it. The problem with the roughness is line or grooves in the casting were usually present, and the cost either improper finishing of wax pattern. That means before you are starting to invest the wax pattern, remove bashing nature wax pattern, you have to finish the wax pattern. That means all the lines and connecting part. Or there is an excess surfactant. That means when you are using the surface tension spray before pouring the investment, you are using excess of it, and this will be like a lumps over the wax pattern, which later on appear as a roughness. Or improper water powder ratio of the investment material, while and excessive burnout temperature. This will withdraw all the moisture in the investment, and this lead to produce porosity on the surface, which later on appear as a rough surface of metal. Also, the nodules. There is a bubble of gas entrapped between the wax pattern and the investment product. Nodules on the casting surface. We have large nodules, we have multiple nodules, and generally caused by either inadequate vacuum during investment, that's because this will lead to produce bubbles and interrupt gas on it, or improper brush technique. That means the way that you are brushing the investment over the design, or the lack of surfactant. That means you are not using at this step the surface tension spray before you are using the investment. Now the nodules on a colloidal surface, if we have some designs with a colloidal surface, for example, if we are looking for a restoration with a post or pontic, this may be related to excessive vibration on this part. Also, we have fins. The fins are caused by cracking the investments. The fins is like the crack in the investment have been filled with the molten metal, and this look like a fins. These cracks result from, of course, increase in water powder ratio. The pattern too near the edge of the investment, and that's why the pressure within the metal break the investment, leading to produce these fins. A premature heating, that means the mold is still wet, so after burnout still the investment not properly heated. Too rapid heating or a dropped mold. All of these will produce a crack within the investment and then filled with the molten metal to produce a fin. Now, one of the other problems with the castings is incomplete casting. And that's why probably the wax pattern too thin. We should put in our minds that if the wax pattern too thin, the investment and the heat exothermic temperature coming from the investment may be heated this part to make it really delicate, and this will lead incomplete casting. Cool mold or melt, that means the mold when you injecting casting the metal inside the mold is cold, or the melt or the wax is not properly heated to melting point. Or inadequate metal, you are using, for example, 5 ingots for restoration instead of 3. So we should compensate all of these to make sure that the casting will be completely filled, even the main sprue as well. Also, we have incomplete casting with shiny rounded defect. Incomplete, why this appear? Because we have incomplete wax elimination. The process of burnout is not completely done. We should put in our mind that all the wax removed or the residue removed, giving enough time to evaporate the wax, and later on to make sure that all the traces of the wax removed. Otherwise, this will produce incomplete casting with a shiny rounded, and this because of the debris of the wax. Or improper pattern position. Probably this is the one of the problems with the sackback porosity. There is porosity within the design, is improper pattern position, and narrow or and long sprue, which give us in terms of improper pattern position, the position of the pattern should be 6 millimeter away from the borders of the edges of the casting grain. And narrow long sprue, this will affect the melt will be solidified, and this will be with the there is no reservoir enough to give a metal give a space to solidify. Also, we have inclusion porosity. The inclusion porosity, the particle of investment dislodged during casting, and that's probably due to either the investment is expired or almost expired, or sometimes the particles of the investment on the design it's not fully vacuum mixed. Also, if we have marginal discrepancies, for the design. The wax pattern distorted. So we should put in our mind that everything burnished perfectly, the foot dome, the shoulders, the external finishing line, internal finishing line should be perfect. And the marginal discrepancy also related to uneven expansion, and this either related to the expire of the material, or probably the powder water ratio, because if you follow the recommendation by the company, you will probably achieve a proper casting and successful casting. The last casting problems that we may notice, inadequate or excessive expansion. And this also related to, first of all, the water powder ratio, improper mixing time for the investment material, improper burnout temperature. All of these will lead to improper expansion, and this either will produce shrinkage in the design, so it is not fitted well in the patient mouth, or it's overexpanded. So the proper compensating we should put in our minds to avoid all these problems. Generally, these are mostly noticed problems within the casting. Now, the factors that influence the excellence of dental casting we should put in our minds is care and accuracy with which the cast is reproduced. The dental technician should be careful and accurate in their work to reproduce the in term of casting, following the steps, the recommendation, the construction, with the investment material, with the casting, the timing, the preheating, all of these should be followed. Intelligence with which the framework is designed and proportioned. That's mean if the design probably take 5 ingots, so take 6 to make sure this will have a complete follow the framework. For example, the care and cleanliness in waxing up the cast. If your waxing is perfect and clean, so you after casting you will have only a delicate finish and polish, and that's it. You don't need to over finished or over polished the design. The consideration of expansion temperature, this should be considered whether you are using the casting ringless or metal ring or plastic ring or rings with asbestos or without, the type of the investment. You should put this in your mind, and the type of the metal, because, for example, phosphate powdered investment material is the most compatible with the cobalt chromium, and this being compensated in terms of shrinkage and expansion in investment material and the metal as well. Now, also size, length, configuration, point of attachment, and manner of attachment of sprues. We should put in our mind that the sprues going directly to the most bulkiest area within the design and then connected to the other bars. We should put in our minds that we're using vents. All of these will produce a proper casting later on. And of course, the choice of investment material in terms of alloy as well, the location of the pattern in the mold, whether this is a large or small pattern, U-shape, full palatal, for palate, for mandible, mandibular restoration. Also, the mixing waters amount, the temperature, the spatulation of the investment during mixing, the restraints offers to expand of the investment caused by the investment ring, setting time, burnout temperature and time, the method of casting, whether you are using manual, electronic, or induction, the gases adhere, entrapped, and observed. Mostly within the casting, we have, for example, many ovens. They have a special rod on the backside and the thermometer to observe all the oxides coming from the investment material through the burnout procedure, while others are not. So we should put in our minds to escape these gases in terms of using alternatives. The force used in throwing the metal into the mold should be should be enough. If we notice that the ingot is not enough, we should make sure that reloaded the crucible with metal, melting enough amount of the ingots to fill the mold. Shrinkage on cooling, whether you need to bench cooling or quenching it, scraping, pickling, and so on. The removal of the investment after casting, the way that we removed it gently, the scrapping, pickling, that means electronic polishing, the polishing and finishing itself, and the heat handling this. All of this should be controlled according to the manufacturer, to the recommendation, and of course the skill of the dental technician and the experience will avoid many problems later on. This is all what I have to say regarding the casting. I would like you to prepare for next week this quiz. What are the factors that influence the excellence of dental casting? I'm looking forward to discuss the next topic in terms of finishing and polishing of the removable partial denture restoration. Thank you and take care. See you next week.